So I'm going to wrap it up here with one more fairly quick talk. And really discuss the management implications for what we've brought up today and some of the upcoming research. Why is this important with ravens? Well, for one thing, raven populations are increasing nationwide, particularly in this area, in coastal California, and the northern coast especially. This is a distribution of ravens up in the left-hand corner, and they're increasing in distribution. Some areas in Northern California were even occupied 20 years ago, and you can see they're actually moving east as well. They're turning up in lots of states in the east where a lot of renewable energy development is taking place, following those types of anthropogenic subsidies. And this right here is the trend in coastal California, 690% increase in the last 40 years, according to breeding bird surveys. So a fairly strong evidence that these birds are increasing, and some of the reasons why is really because of us and the anthropogenic resources that we're providing them in order to increase reproduction and survival. One being a food source. Landfills have been shown in the literature to have a strong influence on raven numbers. Distance to landfill actually increases their departure rates, providing them with more recruitment. And this is just one example. We have roadkill, there's cereal crop, all types of other food sources that they could provide their young and increase reproductive rates. We're not only providing them with food, but with home as well. This is a transmission line. It's not so much important on Alcatraz Island, but throughout the West becoming very important, which is serving as source populations for other areas, such as Alcatraz Island, where we have transient ravens visiting that island. And this is one example again. We have billboards, cell towers, those types of things that they're placing their nests, and it's been shown that their survival rates are higher in these subsidies, probably because they don't have the natural predation that they would have in a tree or a cliff face or something like that. As a matter of fact, the only predator that's been known in this type of setting is a raven itself. So their survival rates and their reproduction rates are increasing drastically. Really, we should do something about it. It's a conservation concern. So it brings about an idea of managing ravens. One way of managing ravens that probably is the most effective and has the most long-term benefit is reducing the anthropogenic subsidies. This is kind of kicking the legs out from under what's causing the problem in the first place. Doing something about the transmission lines, the food sources, those things. Another, discouraged settlement by more ravens. In other words, when you remove territorial pairs, you may have a lot more ravens invade that are more tolerant of each other. Transient ravens that are not really in their reproductive state yet and looking for food. Territorial ravens are defending those areas. Although opposed to that, territorial ravens know the area very well, and it's been shown through a lot of Bill Gorman's research on desert tortoise that they know right where to hunt, and that we think this is probably happening on Alcatraz Island. And they can focus on specific food sources at those locations. But in any means, we should be discouraging reproduction. If you have a territorial pair established, then preventing them from reproducing, you're kind of getting the benefit of them protecting the area from other transient ravens, while they're not contributing to the greater problem of raven increases, not providing more for the Bay Area owners. So boiling the eggs is probably something that might help out in that aspect. And as the research points out here, that focusing mostly on the early nesting season is most important for this colonial nesting birds to prevent this culling effect that's taking place if they're focusing on these specific colonies. So there's some timing implications here as well. So our next step is, which Brianne is going to help a lot of this research in a graduate program at UC Davis. Do gulls negatively or positively influence nest survival rates? Back to the question earlier. This is an important one because they could have direct impacts that are negative, but they may also have positive impacts because gulls are also defending their nest from ravens. And this might be something that is important, or showing some signs of evidence that this might be the case out there. So it's a hypothesis. We'd like to measure it and know exactly what's happening less vigilance when they're near these in the rubble pile, which is right next to a gold colony. That's just a hypothesis. That's what we're looking into measuring, is protected species hypothesis. So we're going to incorporate goal hypotheses into those models that I brought up earlier. So we basically have a nice running model going that we've kind of established from the 21-year data set. And now we can look at some of these other variables and test them up against that model and see if that represents more variation in our survival estimates, which would support this protection species hypothesis. And we want to evaluate interactions between other species, vegetation, timing, and predators on the two response variables, one being predation through mass survival, and direct predation, because we have estimates of predation with our videography. So we can actually model what factors are influencing raven predation specifically, and then also on nesting density. That would be another response variable. So I'm just going to bring up a little bit of data on the gulls that we've collected this year, and show you a little bit how we can actually do this, how we can relate it to night-herons. So these are preliminary spatial measurements of gull colonies. These are all the gulls that were documented on the island this year from our surveys. And our data are very, there was two types of surveys that were taking place. We did a survey, the Fowler Institute also conducted a survey. They were remarkably similar in the results, in the resulting numbers. I think we were only 2 off for Western gulls. The red points indicate those that were GPS, and the green points indicate those that were recorded using binoculars, and then we, from the binoculars, we used landmarks, and we kind of walked around with maps and got precise measurements. It actually turns out that those ones are looking like they were a better method than the GPS method, because we don't have GPS, we don't have satellite here, and the landmarkers are, we can really narrow it down and be precise. So it was that was a nice little map. I'm going to show this graphic here, just so you could get an idea of the coverage on the island of gulls. This was one of the tour helicopters flying over the camp. You can see the 2 colonies, California gulls were down there. We have the cistern. Quite a bit of coverage. There's gulls pretty much occupying the entire island.
Those are gull nests, or?
Gull nests, yeah. So there's a lot more gulls than that, obviously, but these are just the gull nests. So what we did was we conducted a density estimate of gulls using a density estimator, kernel density estimator, and found the appropriate smoothing parameter for these data. And this allows us to look at the probability distribution of gulls nesting across the island and relate that to heron survival. And I'll give you an example of how we can do that. We could take a buffer distance around the raven's nest, and between the high and the low density, each of those pixels represent a different value. We could sum up the values within those buffer distance to give a density index for that individual heron nest and how it relates to gulls. So for example, a heron nest out in here is going to have very low density, whereas one in the rubble pile, rubble west over here, is going to have very high density. So then we can use that as a covariate in survival models. These are the different colonies, and this provides a really nice way to actually figure out what the colony boundaries are without going on the ground and walking around, but using an actual density estimator where we can estimate based on isoplots, 50, 75%, and 95%, we could estimate the boundaries of those, and 50% meaning that 50% of the probability distribution lies within that isoplot. And then we increase 75% and 95%. Now with this, like I said, is a good way to figure out what the boundaries of the colony are. And this right up here, which isn't, as I understand, a colony that is monitored very often, but it's just as much a colony according to this 50% isoplot as these 3 as well. It's a separate colony But anyway, when we put it back on the map, we can see where these different colonies are and where the nests are in relation to that. And then we can develop some different measuring metrics for to relate it to heron's nests. So we have a nearest distance to a gull's nest, and then we can look at things like the amount of distribution or density within that particular buffer distance. We could look at different buffer distance sizes based on movement parameters of herons, and then we could also look at the distance to the different colony edges and use an information theory to find the best metric here that represents this relationship. And this is some of the research we're going to be conducting in the next couple of years, hopefully. So the implications for this and all the research that we have talked about today is to manage and increase numbers of herons within subcolonies. There's a lot of variation within these subcolonies and survival probabilities, and what tended to be the most important was the numbers that are within those subcolonies, and the numbers island-wide. So as you're increasing the number, you're also not just proportionally increasing the survival probabilities, but those probabilities are increasing at a much greater rate just because it's dependent on that number, as that one graphic showed with the predator satiation effect. As far as raven management, this is an important predator, as we've pointed out in lots of different forms of evidence here, especially during the early nesting period. We should be identifying direct and indirect effects of gulls during the reproductive period. They may be serving as protection if they're not, in fact, depredating eggs, or they could be depredating eggs. That might turn up in our findings. So this is something that we need to look into. If they are serving as some kind of protection, then there may be some optimal size of gull nest that would promote heron. This negative trend in heron survival may reverse that over time. Something that we can start to identify how many gulls on the island help improve heron nests if that's the case. And not just that, but the distribution of gulls across the island, not just the number. Nevertheless, identifying the interactions between habitat, proximity of gulls, and also other species on the island is going to be important in just managing this one species. So managing multiple species and their interactions and in relation to habitat factors is, I think, a very important approach to take. And with that, we've had acknowledgements up here, but this is another acknowledgements on some of the 21-year data set, anyway, the research there, field contributions, and technical assistance.